Good morning, guys. How's it going? So, topic we're covering today, guys, is so the Math 20-1 in our sequences and series unit over here, and the topic over here is called sigma notation. Okay, now, guys, this topic is not part of the regular Math 20-1 curriculum, but this is going to be something that we're going to cover as a part of our AP course over here. Now, guys, if you are in regular 20-1, I still recommend that you guys take a look at this notation. This is something that you will see in your future math courses right now, so it's definitely not going to be it's going to be worth your while, I think, to be able to learn this stuff right now. Okay, so it's called sigma notation. Okay, now sigma, guys, this is a Greek letter. Okay, and so that what you see over here, guys, this weird looking E over here is the Greek letter sigma. Okay, now it just this means something. We'll cover this in a second here. So what this means over here, guys, for example one, determine the sum of 2 plus 8 plus 14 plus ... and we want to figure out S5. Well, first of all, guys, we don't really need a formula for this question. Just for S5, I'm just going to extend this series for 2 more terms over here. And this is just adding 5 numbers up in our calculator, okay? So we have 2 plus 8 plus 14 plus 20 plus 26 equals 70. Okay, now we have a formula that we can use for this guy as well. And that's just kind of good practice over here. This is an arithmetic series over here because we have a common difference. So we have Sn equals n over 2, 2t1 plus n minus 1 d. So then S5 would equal 5 over 2, 2 times 2 plus 5 minus 1 times 4, which is 5 over 2. 4, 5 minus 1 is 4 times 4 is 16, is 5 over 2 times 20. Sorry, guys, I made a mistake here. The common difference is not 4, my common difference is 6. So let's go ahead and fix this here. 5 minus 1 is 4 times 6 is 24. So this is times 28. And 5 over 2 times 28. 5 times 28 is 140. Divided by 2 does indeed equal 70. Okay, so we just kind of confirm this answer over here. Now, what does this notation mean over here? Okay, I'm going to argue, guys, that this over here is a way of condensing this series over here. Now, I'm going to show you how that works. What I'm going to start with, I'm going to say if n equals 1. Okay, so we're saying over here, we're looking at this part over here, n equals 1. Okay, then we have 6 times 1 minus 4 equals 2, which happens to be the first term over here. If n equals 2, we have 6 times 2 minus 4 is 12 minus 4, which is 8, which is this term right here. If n equals 3, you have 6 times 3 minus 4. 18 minus 4 is 14, which is the third term here. If n equals 4, you have 6 times 4 minus 4. 24 minus 4 is 20. If n equals 5, you get 6 times 5 minus 4, which is 26, which is our last term here. Okay. Now, and the reason why I'm stopping at 5, guys, we're starting at n equals 1 here, and we're ending at n equals 1. Okay. So I'm going to say starting at n equals 1, and we're ending at n equals 5. Now, what this weird E, or the sigma sign, stands for is the sum of. Okay, so the sum of means we're going 2 plus 8 plus 14 plus 20 plus 26, which is the same thing we did over here. Okay, so I'm going to say, guys, this sum, I know big equal sign over here, is equal to 70, the same answer that we had for this guy over here. Okay, so sigma notation is a tool that we use to be able to condense condense a series. Okay. Example 2, we have from n equals 1 to 7, the sum of negative 3n plus 28. Okay. So if we have, so n equals 1, we have negative 3 times 1 plus 28 is 25. N equals 2, we have negative 3 times 2 plus 28 equals 22. Guys, as I'm doing this, I hope that you're thinking, isn't there a faster way to do this calculation here? And that was kind of the purpose of this part of the of this unit. Okay, do we have a faster way than writing out the whole thing? And we definitely do. So if n equals 5, we have negative 3 times 5 plus 28. Guys, so we have formulas. We have an arithmetic series formula. So the point we're trying to get at, guys, this sum is going to be the same thing as 25 plus 22 plus 19 plus 16 plus 13 plus 10 plus 7, and that's going to equal, I'm just using my calculator for this, guys, equals 112. Okay, or we could have used our arithmetic series formula. So in this case, we're going to figure out S7 is 7 over 2, 2 times 25 plus 7 minus 1 times common difference is negative 3. This gives the same answer of 112 when we do this calculation over here. Okay, so guys, I hope you kind of get how this sigma notation works. Okay, all right. So did you ever hear, guys? Just want to back up for a second. What we're trying to get over here, guys, are we okay that this is the general term of our arithmetic sequence here? And so if we're looking at this guy over here, how would we figure that out? Tn equals T1 plus n minus 1 d. That would be 25 plus n minus 1 times negative 3 is 25 minus 3n plus 3 equals 28 minus 3n. Okay, so purpose over here, this is a general term of our arithmetic sequence. Okay, now what I'm trying to get over here, this is also going to be a general term, but this is no longer going to be an arithmetic sequence. This is going to be a geometric sequence instead. Okay, now here's something else a little bit different. In this case, I'm not starting at n equals 1 like I did in the last one. I'm actually starting at n equals negative 2. Okay, so what would my first term be? My first term would be 16 times negative 2 to the negative 2 minus 1. That's 16 times negative 2 to the negative 3, which is 16. Because remember the way we do with negative exponents, this would become 1 over negative 2 cubed, like this, which is 16 times negative 1 over 8, which is negative 2. Okay, now I'm just going to do one more term here, guys. So if I put in, so this is when n equals negative 2. Let's do when n equals negative 1. Okay, so we're always counting up from this term, ending at this term over here. When n equals negative 1, we get 16 times negative 2 to the negative 1 minus 1, which is 16 times negative 2 to the negative 2, which is 16 times 1 over negative 2 squared is 16 times 1 over 4, which is 4. Okay, so let's do one more when n equals 0. We have 16 times negative 2 to the 0 minus 1 is 16 times 1 over negative 2, which is negative 8. So this becomes like a minus 8. Okay, so really what we want to do here is we're calculating this series over here, negative 2 plus 4 minus 8 plus dot, dot, dot. Now, how many terms do we have? Okay, well, so in this case, how many numbers do we have here from n equals negative 2 to n equals 4? Well, 1, 2, 3, 4, 5, 6, 7. Okay. Now, if we go 4 minus negative 2, that's only 6, but you have to remember that we're counting the number 0 in this case over here as well. Okay, so we're going to have 1, 2, 3, 4, 5, 6, 7. So really we're doing like S7 for this series over here. Now I'm just going to take a look at my geometric series here and I have a formula for that. Sn equals T1 r to the n minus 1 over r minus 1 is negative 2. Okay, my common ratio is negative 2 to the n, which is to the power of 7 minus 1 over negative 2 minus 1. So I'm just going to fire this into my calculator here. I get an answer of negative 86. Okay, so example number 4, write using sigma notation. Okay, now taking a look at this for a second here, guys. 12, 16, 20, 24, 28. I hope you recognize that this is an arithmetic series over here. What I'm going to do is I want to figure out what the general term is of this guy. So I'm going to look at my arithmetic sequence formula, which is this guy here. So it's 12 plus n minus 1 times 4, which is 12 plus 4n minus 4, which is 4n plus 8. Okay, so this can be my general term of this one. So here's what we're going to do. So there's my sigma sign. I have 1, 2, 3, 4, 5 terms. So I'm going to start from n equals 1 until n equals 5. And now I'm going to put my general term right here, which is 4n plus 8. Okay. For the sake of verifying this works, when n equals 1, 4 times 1 is 4, plus 8 is 12. N equals 2, 4 times 2 is 8, plus 8 is 16. When n equals 3, 4 times 3 is 12, plus 8 is 20. When n equals 4, 4 times 4 is 16, plus 8 is 24. 4 times 5 is 20, plus 8 is 28. And that's when n equals 5, which I stop. Okay, so this is kind of just verifying. You don't need to show this work, guys. This is all you would have needed to show for a question like this over here. Okay, similar type of question, except now we have a geometric series instead. So this is 2 minus 6 plus 18 minus 54 plus 162. Hopefully you can see, guys, that our common ratio is negative 3. So again, we have 5 terms. So I'm going to go the sum from n equals 1 to n equal to 5. We don't need to put the n equals. We can just put a 5 here. Okay. Our general term for our sequence here is t1 r to the n minus 1, which is 2 times negative 3 to the n minus 1. And there's our answer right there. All right, guys. I have a quick little assignment for you guys to work on this topic over here, guys. So I will you should have this in your messages in D2L as well. Guys, I hope that this makes sense over here, and just shoot me a message if you have any questions about sigma notation. Okay, see you soon.